Imagine spending $12 billion, nearly a decade of engineering genius, the lives of the brightest minds in American aviation, only to watch your masterpiece become useless before it ever fired a single weapon in anger. Imagine building the most advanced aircraft ever conceived by human hands, machines so far ahead of its time that engineers had to invent entirely new metals, entirely new fuels, entirely new theories of aerodynamics just to make it fly. And then watching a single cheap missile fired from the ground make the entire program pointless overnight. That is the story of the XB-70 Valkyrie. And if you think you already know this story, I promise you, you do not know the half of it. Welcome. Today we are going inside one of the most fascinating, most controversial, most heartbreaking chapters in the entire history of military aviation. XB-70 Valkyrie was not just an airplane. It was a dream. It was an obsession. It was a monument to American ambition during the most dangerous era the world had ever known. It was also, depending on who you ask, the greatest aircraft ever built or the most expensive mistake in the history of the United States Air Force. By the time this story is over, you are going to understand exactly why brilliant men fought and bled politically to build this machine, why it shook the entire philosophy of strategic bombing to its core, why it killed people who loved it, and why, even today, more than 60 years after its first flight, XB-70 Valkyrie remains one of the most jaw-dropping machines ever to leave the ground. Settle in. This one is going to take a while, and every single second is going to be worth it. To truly understand the Valkyrie, you have to go back, not just to the drawing boards of North American aviation in the mid-1950s, but all the way back to the final days of World War II, because that is where the seeds of this entire story were planted. The United States dropped atomic bombs on Hiroshima and Nagasaki in August of 1945. The world changed in a single blinding flash. The nature of warfare changed. The nature of power changed. The nature of fear changed. Suddenly, every nation on Earth had to reckon with one terrifying new reality. The side that could deliver a nuclear weapon to its target first had an almost incomprehensible advantage. Almost immediately, the United States and the Soviet Union began a race that would define the next 50 years of human history. A race to build bigger bombs, faster planes, longer ranges, and more devastating weapons of mass destruction. This was the Cold War. And the XB-70 Valkyrie was born directly from its fever dream. Years immediately following World War II, the United States Strategic Air Command, known simply as SAC, was the tip of America's nuclear spear. Under the iron command of General Curtis LeMay, of the most formidable military figures of the 20th century, SAC operated fleets of heavy bombers whose sole purpose was to carry nuclear weapons deep into Soviet territory if the order ever came. Workhorses of this mission were propeller-driven behemoths like the B-29 and later the B-36 Peacemaker, massive aircraft that could carry enormous bomb loads but were painfully slow by modern standards, understood that speed was survival. A slow bomber over heavily defended Soviet airspace was a flying coffin, and so from the very beginning, SAC was pushing, always pushing, for faster, higher, farther. 47 Stratojet arrived in the early 1950s and changed the game dramatically. Here was a swept wing jet bomber that could actually outrun many contemporary fighter aircraft came the magnificent B-52 Stratofortress, which entered service in 1955 and became arguably the most successful military aircraft in American history. A machine so well designed that it is still flying combat missions today, more than 70 years after its introduction. As the B-52 was rolling off the production lines, the visionaries at SAS and at the Air Force were already looking beyond it, because the Soviet Union was not standing still. Soviet engineers were developing their own jets, their own interceptors, radar networks. The window of American air superiority was not going to stay open forever. And so, 1950s, the United States Air Force issued one of the most ambitious, most demanding aircraft requirements in the history of military aviation. The requirement had a name that was almost comically understated. It was called Weapon System 1A. What it demanded was anything but modest. Air Force wanted a strategic bomber that could fly at 3 times the speed of sound, Mach 3, at altitudes above 70,000 feet, with a combat radius of approximately 4,000 miles. Think about what that means for a moment. Mach 3 is roughly 300 miles per hour. At that speed, you could fly from New York to Los Angeles in about 1 hour and 15 minutes. At that altitude, you are at the very edge of the atmosphere, a realm where the sky above you begins to turn from pale blue to the absolute black of space. Bomber had ever come close to those numbers. No bomber had even dreamed of those numbers. Yet here was the United States Air Force, in dead seriousness, asking American industry to build one. The companies that received this requirement looked at the numbers and understood immediately that they were not being asked to build a better airplane. They were being asked to reinvent what an airplane could be. Several companies submitted proposals, but the competition ultimately came down to 2 giants of American aviation and North American aviation. Boeing's design was a radical nuclear-powered concept that was ultimately deemed too dangerous and too complex. North American Aviation, the company that had given the world the legendary P-51 Mustang and the sleek F-86 Saberjet, came back with a design that was breathtaking in its ambition. Their proposal was for a massive delta-wing aircraft powered by 6 enormous turbojet engines capable of sustained Mach 3 flight at extreme altitude. North American won the contract in December 1957. The program that would produce the XB-70 Valkyrie was officially born. Now here is where the story starts getting truly remarkable, because building an airplane that can fly at Mach 3 is not simply a matter of making a faster engine or a bigger wing. At Mach 3, the entire physics of flight changes in ways that are almost violent. The air resistance at those speeds generates heat. Tremendous, ferocious, structural, threatening heat. When a conventional aluminum aircraft flies at Mach 3, the friction of the air against the skin of the aircraft generates temperatures that would literally cause aluminum to soften and lose its structural integrity. The skin of an XB-70 flying at cruise speed would reach temperatures of 330 degrees Celsius in some areas. That is hot enough to bake bread. That is hot enough to cause serious burns on contact. That is hot enough to destroy virtually every conventional aircraft material that existed in the 1950s. North American's engineers faced a challenge that had no precedent and no textbook solution. They needed materials that were light enough to fly, strong enough to withstand the mechanical stresses of supersonic flight, heat, resistant enough to survive for hours in a Mach 3 environment. Their answer was a material called stainless steel honeycomb. Sheets of stainless steel, brazed together in a honeycomb pattern, provided an extraordinary combination of strength, lightweight, heat resistance. It sounds almost simple when described that way. The reality of manufacturing it was anything but. Techniques required to produce and work with stainless steel honeycomb at the scale required for the XB-70 essentially had to be invented from scratch. Welding methods, new bonding techniques, quality control procedures, all of it developed specifically and exclusively for this one aircraft. But the materials problem was only the beginning. At Mach 3, engines breathe air at such high velocities that conventional engine intake designs simply do not work. The air coming into the engine must be slowed down from supersonic speeds to subsonic speeds before it reaches the compressor face. The engine will choke and fail. This process of slowing and compressing incoming air is called intake compression. Designing an intake system that could do this efficiently across the enormous range of speeds the XB-70 would encounter from takeoff at 0 miles per hour all the way to Mach 3 cruise was a problem of staggering complexity. North Americans engineers developed a variable geometry intake system of remarkable sophistication, with movable ramps and bypass doors that continuously adjusted the airflow to maintain optimal engine performance. Throughout the flight envelope, there was the matter of fuel. At Mach 3, the XB-70 would consume fuel at a rate that was almost alarming, but the fuel itself presented another extraordinary challenge. Standard aviation fuel, JP4, would actually begin to degrade at the temperatures encountered during Mach 3 flight. Answer was a specialized high-density fuel called JP6, developed specifically for the Valkyrie program. JP6 had a higher flash point and greater thermal stability than conventional aviation fuels, and it was also denser, which meant more energy could be packed into the same volume of fuel tank space. The entire fuel system of the XB-70 was designed around the unique properties of JP6. Aircraft carried it in multiple fuselage tanks that also served a secondary purpose as thermal heat sinks, absorbing some of the heat generated by the airframe during high-speed flight. And then there was the wing. Oh, that wing, XB-70's massive delta wing, was one of the most visually striking features of the entire aircraft, spanning 105 feet from tip to tip and creating a platform of almost hypnotic geometric beauty when seen from above. The wing was not just beautiful. It was the key to one of the most ingenious aerodynamic tricks ever incorporated into a military aircraft. At Mach 3, XB-70 would actually ride on top of its own shock wave, a phenomenon called compression lift or wave riding. As the aircraft flew, it generated a powerful shock wave beneath its delta wing. By designing the wing to capture and ride on top of this shock wave, North Americans engineers were able to generate additional lift, essentially for free, reducing the fuel consumption required to maintain cruise altitude and speed. It was a concept that was theoretically understood, but had never been demonstrated in practice at this scale. It was, in every sense of the word, revolutionary. The wingtips deserve their own special mention. One of the most distinctive visual features of the XB-70 was its ability to fold its wingtips downward during high-speed flight. Those massive outer wing panels, each one roughly the size of a small fighter aircraft, drooped downward by up to 65 degrees. This served two purposes. First, it helped contain the shock wave beneath the wing, improving the compression lift effect and increasing aerodynamic efficiency at cruise speed. Second, improved directional stability at high speeds by effectively increasing the side area of the aircraft and moving the aerodynamic center in a favorable direction. The engineering behind this folding wingtip mechanism was itself a marvel of mechanical design, requiring actuators and pivot mechanisms that could operate reliably at the extreme temperatures and aerodynamic loads encountered during Mach 3 flight. By the time the design of the XB-70 was finalized, the aircraft had grown to proportions that were simply staggering. The Valkyrie was 185 feet long, longer than many of today's passenger airliners. It stood nearly 31 feet tall at the tail. Its maximum takeoff weight was 550,000 pounds, more than 250,000 kilograms. Was powered by 6 General Electric YJ93 turbojet engines, each producing approximately 30,000 pounds of thrust with afterburner. Those 6 engines together could propel this enormous machine to speeds that no bomber before or since has ever matched in sustained flight. XB-70 was not just big, it was magnificent. It was the physical embodiment of American industrial and technological power at the absolute peak of the Cold War arms race. But while North Americans' engineers were bending metal and pouring sweat into their miracle machine out in Palmdale, California, something was happening in the wider world of military technology that would ultimately seal the Valkyrie's fate. October 4, 1957, the Soviet Union launched Sputnik into orbit. That tiny aluminum sphere, beeping its way around the Earth, sent a shockwave through the American defense establishment that is difficult to overstate. If the Soviets could put a satellite in orbit, they could put a nuclear warhead on a ballistic missile. A ballistic missile, unlike a bomber, cannot be shot down by fighter aircraft or surface-to-air missiles of the era. Implications for strategic deterrence were seismic. The age of the intercontinental ballistic missile had arrived. Almost simultaneously, another development was threatening the XB-70's rationale from the other direction. On May 1, 1960, CIA U-2 reconnaissance aircraft piloted by Francis Gary Powers was shot down over the Soviet Union. The U-2 flew at approximately 70,000 feet, roughly the same altitude the XB-70 was designed to operate at. It was brought down by a Soviet SA-2 guideline surface-to-air missile. In a single stroke, the fundamental strategic assumption underlying the entire XB-70 program, that a high-flying, fast-moving aircraft could evade Soviet air defenses, was called catastrophically into question. If a relatively slow reconnaissance aircraft could be knocked down at 70,000 feet, what did that mean for a bomber that would need to make predictable ingress and egress routes that would show up on radar screens hundreds of miles before reaching its target, that would need to slow down and fly straight during a bombing run? Pentagon and the Eisenhower administration had already been growing uneasy about the XB-70 for cost reasons. Program was expensive beyond almost any peacetime precedent. The original estimates had grown and grown as the technical challenges multiplied. Robert McNamara became Secretary of Defense under President Kennedy in 1961. He brought with him a philosophy of systems analysis and cost effectiveness that looked at the XB-70 and saw a program that was pouring money into a capability that ballistic missiles could provide for far less cost. McNamara was brutal in his assessments and utterly unsentimental about institutional attachments. He looked at the numbers, he looked at the strategic environment, and he began methodically cutting the XB-70 program back. The original plan had called for a fleet of production B-70 bombers that would replace the B-52 as America's primary manned strategic bomber. That plan was reduced first to a smaller production run, then to a development program, to a pure research program involving only 2 prototype aircraft. General Curtis LeMay, who had staked much of his professional credibility on the B-70, fought furiously to save it. Congressional allies who had defense contracts in their districts fought alongside him. The battles between LeMay and McNamara over the XB-70 were some of the most bitter civil, military confrontations of the early Kennedy era, personal as well as professional, ducted in hearing rooms and back corridors with an intensity that bordered on open warfare. McNamara held the ultimate institutional power, and the program continued to shrink. Despite all of this political turbulence, the actual aircraft were being built. And when the first XB-70A, serial number 62001, rolled out of North American Aviation's plant at Palmdale, California, on May 11, 1964, it stopped everyone who saw it cold. Nothing in the history of aviation had looked quite like this. The Valkyrie was simultaneously futuristic and somehow ancient, a great white shark translated into titanium and steel. Its long needle, like fuselage, its vast delta wing, its canard foreplanes, its drooped wingtips, its 6-engine exhausts gleaming in the California sun. It was utterly unlike anything else that had ever been built. Workers who had spent years building conventional aircraft simply stopped what they were doing and stared. Test pilots who had flown everything from F-86 to X-15s admitted to genuine awe. Even McNamara's analysts, who had been the architects of the program's political destruction, acknowledged that what North American had produced was extraordinary. The first flight of the XB-70A took place on September 21, 1964, with North American's chief test pilot Alvin White and Air Force Colonel Joseph Cotton at the controls. The aircraft lifted off from Air Force Plant 42 at Palmdale and headed east toward Edwards Air Force Base, where the flight test program would be conducted. That first flight lasted approximately 1 hour, while it was not without its minor incidents. The landing gear doors gave some trouble. It was by any measure a triumphant beginning. Aircraft flew. The aircraft flew well. What it would accomplish over the following months would prove that even in political death, XB-70 had more to teach the world about aviation than most aircraft accomplish in a full operational career. The flight test program pushed the XB-70 progressively higher and faster in carefully planned increments. Each new milestone required exhaustive analysis of data from the previous flights, assessment of structural health, review of engine performance, evaluation of systems behavior. The men who flew the Valkyrie during this period were operating at the very edge of human knowledge in an aircraft that had never been flown before at the speeds and altitudes. It was designed for without the accumulated operational wisdom that comes from years of service experience. They were pioneering, most literal sense of that word. On May 7, 1965, the XB-70 achieved sustained Mach 3 flight for the first time. Alvin White pushed the throttles up, pointed the nose of the aircraft east over the Nevada desert, watched the Mach meter climb past 2, past 2.5, and finally settle above 3. At that moment, XB-70 became the largest aircraft in history to fly at 3 times the speed of sound. The numbers from that flight were extraordinary. The aircraft performed essentially as designed. The compression lift effect was real and measurable. The engines ran smoothly. The structural temperatures were within predicted ranges. For everyone who had sweated and struggled and argued and prayed over this program, that day in May 1965 was a moment of profound vindication. The second prototype XB-70A serial number 620207 joined the flight test program in 1965 and was configured slightly differently from the first aircraft. It incorporated improvements identified during early testing and was generally considered to have better performance characteristics. Both aircraft continued their test program through late 1965 and into 1966, accumulating data on supersonic aerodynamics, propulsion performance, structural behavior, systems reliability that would prove invaluable to the development of future high-speed aircraft. The data gathered by the XB-70 program directly influenced the design of the SR-71 Blackbird, Concorde supersonic transport, and numerous other aircraft that followed. And then came June 8, 1966, date that will forever be associated with the XB-70 Valkyrie in the darkest possible way. General Electric had arranged a publicity flight, formation flight for a magazine photo shoot that would show the XB-70 flying alongside several of the jet aircraft whose engines General Electric powered. The formation included the XB-70A No. 2, an F-104 Starfighter, an F-4 Phantom, a T-38 Talon trainer, F-5 Freedom Fighter. The photographer was Joe Walker, one of America's most accomplished test pilots, had flown the X-15 to the edge of space. He was flying the F-104 Starfighter positioned off the right wingtip of the XB-70. During the formation flight, Walker's F-104 drifted too close to the XB-70 and became caught in the powerful vortex shed by the Valkyrie's massive wing. F-104 was flipped inverted and struck the XB-70, shearing off both of the bomber's vertical tail fins. F-104 disintegrated instantly, killing Joe Walker. The XB-70, without its vertical stabilizers and with a rapidly developing roll that the pilots could not control, flew straight and level for several agonizing seconds before beginning a slow, inexorable roll to the right. The aircraft entered a flat spin and impacted the ground near Barstow, California. The co-pilot, Air Force Major Carl Cross, was killed in the crash. Alvin White, the primary test pilot, survived after ejecting in the revolutionary escape capsule, though he was seriously injured. The loss of Joe Walker, one of the finest aviators America had ever produced, and of Carl Cross, of the second and better of the two XB-70 prototypes, was a blow from which the program never emotionally recovered. XB-70A, the first prototype, continued its research program. It flew its last flight on February 4, 1969, was subsequently ferried to the United States Air Force Museum at Wright-Patterson Air Force Base in Dayton, Ohio. It remains today still the most spectacular aircraft in one of the world's most spectacular aviation collections. If you have never seen it in person, I cannot encourage you strongly enough to go. Because photographs, even the finest photographs, simply cannot prepare you for the reality of standing next to this machine. It is vast. It is white and gleaming, and somehow still alive, looking after all these years. It radiates the ghost of speed. Let us take stock of the legacy, because this is where the story of the XB-70 becomes truly rich and genuinely complex. The surface, it is easy to frame the XB-70 as a failure. The program consumed enormous resources, produced only 2 aircraft, never entered operational service, resulted in the deaths of 2 skilled pilots, was ultimately rendered strategically obsolete by technologies that its proponents had either failed to anticipate or had chosen to downplay. That narrative is not entirely wrong. The program did cost an enormous amount of money. The aircraft did become strategically questionable before it ever flew. And the decisions made during the program, both technical and political, deserve serious scrutiny. But that surface narrative misses something profound. XB-70 Valkyrie was one of the most technically ambitious aircraft programs ever attempted. By the standards of technical ambition, it succeeded beyond any reasonable expectation. The aircraft actually flew at Mach 3. The compression lift concept actually worked. The stainless steel honeycomb construction actually performed as predicted. The propulsion system actually functioned as designed. When you consider that the engineers who built the Valkyrie were working in an era before computer aided design, before computational fluid dynamics, before finite element analysis, before most of the analytical tools that modern aircraft designers take for granted. The fact that the XB-70 worked at all is staggering. The fact that it worked this well borders on miraculous. The data gathered from the XB-70 flight test program did not die with the aircraft. It flowed into dozens of subsequent programs, influencing the design of supersonic transport aircraft on both sides of the Atlantic, informing the development of the SR-71 and its engines, contributing to the theoretical foundations of high-speed aerodynamics that still underpin aircraft design today. Very real sense, every supersonic aircraft that has flown since 1966 carries a little bit of the XB-70's DNA. Engineer who has ever designed an intake for a supersonic aircraft has benefited from the work done at Edwards Air Force Base during those brief, intense years of Valkyrie testing. The machine may have been strategically obsolete. The knowledge it generated was timeless. Political story of the XB-70 is also more nuanced than the simple narrative of McNamara's cold-eyed budget axe destroying a brilliant weapon system. The fundamental strategic questions that McNamara and his analysts raised about the manned bomber in the missile age were not wrong questions, were the right questions asked at the right time. History of the Cold War would ultimately vindicate the continued value of the manned strategic bomber. The B-52 proved its worth in ways that nobody in 1961 had fully anticipated. Its successors, the B-1 and the B-2, demonstrated that the manned penetrating bomber remained relevant even in the age of ICBMs and cruise missiles. But the specific case for the B-70 as a production bomber, as a replacement for the B-52, was genuinely weak by the early 1960s. McNamara was not wrong to question it. He may have been wrong in some of the ways he conducted those battles. He was certainly wrong to be as personally contemptuous of military professionals as he sometimes was. But the underlying strategic logic of his position was more defensible than its critics have always admitted. What was lost with the XB-70 was not primarily a weapon. What was lost was a dream of a certain kind of aviation progress. The dream that speed and altitude and raw technological performance could always stay ahead of the threat. That human ingenuity at the drawing board could always outrun the adversary's missiles and radars and computers. That dream did not die with the Valkyrie. It lives on in aircraft like the SR-71, ongoing development of hypersonic vehicles, in the persistent human desire to fly higher and faster. But the XB-70 was perhaps the last aircraft program in which that dream was pursued with such complete, unironic, almost naive faith in the power of American engineering to overcome any obstacle. After the Valkyrie, aircraft programs became more calculating, more systems-oriented, more focused on survival rather than pure performance. Something was gained in that transition. Something was also lost. Who flew the Valkyrie occupy a special place in the pantheon of American test aviation. Alvin White survived the 1966 crash, had a career of extraordinary breadth and courage. Colonel Joe Cotton flew the first flight, was everything the phrase test pilot was meant to evoke. Precise, analytical, unflappable. Killed in that terrible June day. Joe Walker and Carl Cross were among the finest representatives of a generation of aviators who understood that pushing the boundaries of flight required the acceptance of mortal risk. Walker in particular was a figure of near legendary status in the test pilot community who had flown the X-15 faster and higher than almost any other pilot, a man whose death in a formation flight that should have been routine seemed particularly and cruelly unfair. These men gave everything to the pursuit of knowledge about what aircraft could do. The least we owe them is to remember what they died in service of. XB-70 Valkyrie program also tells us something important about the nature of technological ambition and strategic planning in a democracy. The program existed in a political environment of extraordinary complexity. Competing service interests, competing strategic philosophies, competing industrial interests, competing personal ambitions and egos, all playing out against the backdrop of genuine existential threat. The decisions made about the B-70 were not made in a vacuum of pure reason, were made by human beings, operating under enormous pressure, with incomplete information, fog of technological and strategic uncertainty that characterizes the real world of defense decision making. Some of those decisions were brilliant. Some were mistaken. Most were somewhere in between. The program is a reminder that even in the most technically sophisticated endeavors, element, with all its complexity, its courage, its vanity, its vision, its failure, is always the most important variable in front of the surviving XB-70 at right. Patterson today, knowing everything that has been said in this story, you might expect to feel sadness. And there is sadness there. For the program that could have been, for the pilots who were lost, for the dream that was born already dying. But the dominant feeling, at least for me, is something closer to awe. Because what you are looking at is not a failure. What you are looking at is evidence of what human beings can accomplish when they decide, collectively and with total commitment, to do something that has never been done before. The XB-70 Valkyrie flew at 3 times the speed of sound. It flew higher than almost anything else alive. It did what its creators designed it to do, a precision and a grace that took the breath away from every single person who ever saw it in the air. It was born into a world that had already moved past its strategic purpose. Does not diminish the wonder of what it was. If anything, it makes the wonder more acute. The Valkyrie teaches us about the relationship between ambition and timing. The greatest machines, the greatest ideas, the greatest efforts of human engineering and courage do not always arrive at the right moment. Sometimes the world moves faster than the dreamers who are trying to serve it. Sometimes by the time you have built the perfect answer, the question has already changed. That is not a reason to stop dreaming. It is not a reason to stop pushing the boundaries of what is possible. The XB-70 Valkyrie could not have known, as it screamed across the Nevada desert at 300 miles per hour, 70,000 feet above a world that was already leaving it behind. It was giving everything it had to a cause that was already lost. It flew anyway. It flew with everything it had. It flew as beautifully as anything that has ever flown. And for that pure, unbridled, magnificent act of flight, oh, this great white ghost of the Cold War, our deepest and most enduring respect. The story of the XB-70 Valkyrie is ultimately a story about what it means to reach beyond what you know is possible, to build something that exists at the very limit of human knowledge and capability, to send it into the sky and watch it perform with a beauty and a power that makes you momentarily forget every argument about cost and strategy and obsolescence. It is a story about the pilots who climbed into cockpits that were mounted at the top of machines unlike anything the world had seen, flew them into skies that no one had ever flown through before, with courage so matter of fact that it shames the rest of us. It is a story about engineers who solved problems that had no textbook solutions, who invented materials and techniques and approaches to aerodynamics that became the foundation of everything that came after. It is a story about a nation, at the height of its power and its fear, reaching for something extraordinary and actually touching it, if only for a moment, before the world moved on. The great white Valkyrie sits in Dayton, Ohio, silent and still, gathering the quiet admiration of the people who stand before it every day. It will never fly again. Its engines will never howl again across the desert sky. But in the record books of human achievement, technical libraries of aerospace engineering, in the memories of everyone who was lucky enough to see it fly, XB-70 Valkyrie remains exactly what it always was and always will be. The most beautiful, the most ambitious, the most heartbreaking, and in its own profound way, the most magnificent aircraft that America ever built. If you have made it to the end of this story, you understand something that most people never think about. That history is not made only by the things that succeeded. It is made equally by the things that dared. The XB-70 Valkyrie dared more than almost anything else in the sky. For that, it deserves to be remembered, to be studied, to be honored. Not as a cautionary tale, as a footnote in the budget wars of the Kennedy administration, but as what it truly was, A masterpiece, born obsolete, yes, but a masterpiece nonetheless. Now, before you go, I want to leave you with one question to think about. Given everything you have just learned, the billions spent, the technology achieved, the pilots lost, strategic context that made the aircraft obsolete before it ever entered service, do you think the XB-70 program was ultimately worth it? Should America have built this aircraft, knowing what we now know? Or was it a magnificent mistake, consumed resources and lives for a dream that was never going to fly in combat? Leave your answer in the comments. I genuinely want to know what you think. If this story moved you the way it moves me every time I revisit it, please share it with someone who loves aviation history as much as you do. These stories deserve to be kept alive. The Valkyrie deserves to be remembered, and there are more stories like this one waiting to be told. So make sure you are subscribed, because we are just getting started.